What we mean here is that we need to make a definition. The definition says is that power is how quickly work is done. And if I write this as an equation, then we say that the concept of power then reads, it says, how much work is done divided by your time interval. And so when I write this as an equation, I write this as the work divided by time. So this is our definition of power. Okay. And so what I want to do here is that to talk about power, I want to use the analogy that we did with work. I misspoke. I want to use an analogy with work to try to think about power in a very similar way. So as an analogy, remember, work and power are not the same thing. They're related to each other. What we said with work here is that there's two ways to do the same amount of work. And what we found here is that I could have a work where I do what? I have a big force over a small distance or a small force over a big distance. Either way, these two are exactly the same. We can apply this type of thinking to power as well. In other words, there are two ways to be powerful. Okay, there are two ways to be powerful. And you could see that power involves work and time, whereas when we were talking about work, it was force and distance. So work and time are the important pieces here. So what you're finding here is that power depends on work and time. So that's what we got to adjust. So how could we do this? Well, I could have a work that's this big. And if I now come in here and I change the time to be really small, so this gives me a small time. And what does a small time mean? It means quickly. And another way that we can do this is that we could have a really big work. Where in this case, the time doesn't matter. All this is saying here is that this guy is how do I say it? This is a large amount of work. And typically when we say a large amount of work, this means you can think of this as big loads. So if I do this just right, what you're going to find here is that these two can actually be the same. So then we can be powerful two different ways. either we do power quickly. So what we say here is that, so one can be powerful two different ways. One is do work quickly. And this guy involves the concept of what? Or I can have a carry a large load. And in this situation, we're talking about work. So let's go put that together. So what the first thing that we want to talk about then is we want to talk about what? Doing work quickly. And that involves time, right? That involves time. So cars, oh, why did I write power? Cars are judged as powerful by how quickly they go from 0 to, let's say, 60 miles an hour. Right? So cars are judged by how powerful. Ooh. Well, that doesn't make any sense, does it? Cars are judged how powerful by how quickly they go from 0 to 60. I think that's okay. So let's do this. So clearly, I'm going to draw a slower car. And then I'm going to have a faster car. Let's say that this is the faster car. So that means that the slower car is going to take longer to go from 0 to 60 miles an hour, whereas the faster car is going to take less time to go from 0 to 60 miles an hour. So let's set up that situation. So the situation that I want to look at here is that here we go. I got to draw a car. So here's my car. And I'm going to say that this is my blue car. And I'm going to say that this blue car here is going to start off at 60 miles at 0 miles an hour. Okay, so that means this car starts off at 0. And then what we need to do is that we need this car to now get to 0 to 60 miles an hour. So then this means here that this car is now going to reach 60 miles an hour. So if this car is a slow car, we're going to say that this car goes from 0 to 60 miles per hour in a time of, let's say, 15 seconds. So what does a faster car do? Well, let's say that I have a faster car. So what I imagine here is that now I have this car, and when I look at this car, it has a bigger engine. It's a sports car. So maybe we come in and we draw this red car, right? A nice flashy looking car. And so what I want to do here is that I imagine that if this is a faster car, it can accelerate quickly. So what I'm going to see here is that as I do this, this car is going to take a shorter amount of time to do what? To reach 60 miles an hour. So if this car starts off at 0, then we're going to go that this guy goes from 0 to 60 miles an hour in a time of, let's say, 10 seconds. So you can see here is that when I compare this value right here to this value, this car was faster. So the question is, what do I mean by this? Well, let's go look at this thing here. I'm going to assume that each of these cars do the exact same work. They weigh the same. Okay, so these cars both weigh the same. So when I look at the force and the distance, then I have this type of thing here, right? I have the work. And what you're going to find here is that the blue car took what? It took longer. So in other words, when I look at its time, it is very, very big. But when I look at the red car took a little bit of time. So what you're seeing here as a consequence, because it has a small time, it's going to be bigger. And when I look at the blue car, it's going to be smaller. So what do we say here? This here is less powerful, and this guy here is more powerful. So then we get something like this. So what's a powerful car? What would I call a powerful car? This guy right here. So what you're seeing here is that if you look at this car, there's a base price. The base price here of this car is $1.9 million. Pretty expensive. So then it could have a top speed. Can you hold on a second? There's a lot of noise. I need to close the window. Sorry about that. So let's keep going here, okay? So there's a top speed of this car, turns out to be 331 million miles per hour. And so when you look at their top speed, just to give you a sense, they claim from 0 to 60 miles an hour is in 3 seconds. That's a powerful car, right? That is a very, very powerful car. So let's go to the next one. So the next one, the other way that you could be powerful here is that carrying large loads. Okay, carrying large loads. So what I want to do here is that when you're carrying large loads, you want to think about the size of the car, I guess, or the engine of the car. And I could set up 2 different situations. So one thing that I can do is I could come and I could take this little blue car. Now, if I think about this little blue car here, I could imagine that I have a small car. And if I have a small car, what you're going to imagine here is that this little car here has to carry a load. So what do I mean by that? Well, since it's a small car, we know that it's going to be moving And let's say that you're going to go, let's say, a large distance. So what do you find here? Because this is a smaller car, it carries a smaller load. So in this case, this is a small load. On the other hand, we can have a big truck. So if I have one of these really big trucks that people use, right? You're gonna see here is that these trucks here, right? They got the back, and typically it goes straight up, they go like this, then they come out like this. And when you're looking at these trucks here, you might have a truck something like this. So in this scenario here, let's imagine that we're sporting this green truck. And so when I'm looking at this truck, it's built to do what? Carry really large load. So you could imagine this guy is just a really big load. And so when you're looking at this large load here, you're going like, oh yeah, this guy is a large load. So as this truck moves this large load, what we say here is that this truck is more powerful at carrying large loads, whereas this car is less powerful because it can only carry small loads. So there's a difference between these two. And when I think about our work equation, we could imagine here that the time in each situation will be exactly the same. So what's the difference? The difference here is that the car can only do a little bit of work, and therefore its power is really small. That's not true of the truck. It could move a huge load, and as a consequence, it is more powerful. And a clear image of this is this thing right here. Look at this truck right here. That is a huge load. So that truck is designed to carry big loads. And that's what we call what? A powerful truck, without any doubt. So this is without any doubt a powerful truck. If I tried to do that in my Nissan Leaf, right, it would be a joke. So one last thing before we move on. And the thing that we got to do here is that I want to look at the units of power because they might be of some use just because you see these units. So let's look at a unit of power. So a unit of power means that you need what? A unit of work, and that's what we call a joule, right? And then we have a unit of time, and this is what's called a second. So when you combine these for power here, you got to look at what? Work divided by time. So the unit of work is a joule, And the unit of time is a second. And this is what they call a watt. And I'll tell you what I find really strange. We talk about units of watts all the time. By the way, that's a metric unit. Why do we use a metric unit for power and not for anything else? Well, that's a good question. I have no idea. So the question is, why do I even talk about this? As an example, we all pay PG and E electric bills. So I want to talk about PGE electric bills. So you may have noticed that PG&E charges you in units of work, even though people say, oh, it's watts. It's watts. And the way you got to think about this here is that you got to look at it this way here. So when we look at power, it's equal to work divided by time. There's another way that we can rewrite this thing. We can also write this as work is equal to power times time. So what are the units of PG&E? Well, PG&E charges you in what? Look at this. Kilowatt. They charge you in kilowatts. Even though they call it a kilowatt hour, it's really kilowatts. So kilowatts is without a doubt a unit of power, because now it's in thousands of watts. And then you have a second unit, which is hour. And that, of course, is the time. So they typically put a hyphen for a kilowatt hour like this. And look at this. Power times time is what? Is work. So PG&E charges you not in kilowatts, but watt hours, kilowatt hours. So what does PG&E actually do? Well, what PG&E does is that this work is the work required to move current through your home or apartment. Technically, it's the work done to move the electrons and the wires in your house. That's what work is.